Hi, mathletes. Today we're going to look at three different forms of representing ratios. And the three are the double number line, the tape diagram, and graphing. These are three visual ways of representing ratios. Let's start with the double number line. Our question is, the number of people with glasses is 4, and the number of people without glasses is 6. If there are 10 people with glasses, how many people do not have glasses? Since we're using a double number line, we'll have two number lines. The top number line will be the people with glasses, and the bottom number line will be the people without glasses. And what we know about the ratio is the number of people with glasses is 4, and the number of people without glasses is 6. So I have my 4 and my 6 lined up. Notice they're the same distance from 0, even though they're different numbers. What else I know is that there are 10 people that have glasses, so I put my 10 here. Now I'm trying to visualize this in equal increments, so that's why the distance between 0 to 4 is shorter than the distance between 4 and 10. I'm trying to figure out how many people do not have glasses if 10 do have glasses. So I put that number line or the line for it right underneath the 10 with my question mark because that's my unknown. So now what we're going to do is we're going to actually put in the tick marks or the increments. So here I have my numbers 1, 2, 3, and 4, and I'm going to continue on to 6, 5, 6, 7, 8, 9 to 10. I'm going to do the same thing with the second number line. Notice that these increments are shorter than the top because the distance from 0 to 6 has 5 of them. So we have 0, 1, 2, 3, 4, and 5. And then from 6 to my unknown, I put in my numbers and I have 7, 8, 9, 10, 11, 12, 13, 14, and 15 lines up with 10. Therefore, 15 people do not have glasses when 10 do have glasses. So there are 15 people who do not have glasses. But did you notice anything else about the two number lines? You can pause the video here to think about it and then just resume it when you're ready. All right, this is what I noticed. I noticed that not only is it 10 and 15 are the ratio that is equivalent to 4 to 6, but 2 to 3, 6 to 9, and 8 to 12 are all equivalent ratios. Now let's look at tape diagrams. If you want to learn more about tape diagrams and see more examples, you can just use this QR code. You can pause the video here so you can take a picture of it and then just hit resume when you're ready. So for the tape diagram, we're going to use the question with lemonade. So lemonade is being made in a ratio of 4 cups of water to 3 cups of lemon juice. If there are 21 cups of lemonade, how many cups of water and how many cups of lemon juice are needed? So we're going to start out with our ratio with the cups of water. I have 4 cups of water, so I'm going to show that using my tape diagram where each one of the 4 squares equals a cup. So 1, 2, 3, 4 cups of water. Then I have 3 cups of lemon juice. So for my lemon juice, I have my 3 squares representing the 3 cups, which gives me a total of 7 cups. 1, 2, 3, 4, 5, 6, 7 cups. If I want the total to be 21 cups of lemonade, I can divide my 21 cups of lemonade by my 7 total cups of water and lemon, and I get 3. Therefore, each one of the squares has to equal 3. So for the water, it's 3 multiplied by 4, which is 12. And for the lemon, it's 3 multiplied by 3, which is 9. So for 21 cups of lemonade, you would need 12 cups of water and 9 cups of lemon juice. And just to check to make sure that this checks out, you can add the 12 and the 9, and the sum does equal 21. Now let's look at our third one, which is graphing. A recipe calls for a ratio of 1 cup of sugar to 3 cups of flour. If we use 3 cups of sugar, how many cups of flour are needed? So let's write this ratio as sugar to flour. And what we know is the ratio is 1 to 3. If I double both the 1 and the 3, I end up with 2 to 6. 1 multiplied by 2 is 2, and 3 multiplied by 2 is 6. Let's double that. So 2 multiplied by 2 is 4, and 6 multiplied by 2 is 12. Now that I have these three ratios, I can use them as a graph. So I can graph. So these are three different ordered pairs. So when I set up my graph, I'm going to put my sugar as my x-axis and the flour as the y-axis. And then I can plot the points. So the first point was for the sugar being 1 and the flour being 3. So 1, 3. So sugar and flour. My second point is 2, 6, and my third point is 4, 12. Now I notice that they line up, so I can draw a line and notice it's a linear function. And now that I have my line, I can try to figure out my 3 cups of sugar. So I go over and I find where the 3 is, and then I draw a dotted line up, and there is my 3 cups of sugar, and then I'm going to go horizontally across, and it looks like it's at the number 9 cups of flour. So therefore, I would need 9 cups of flour for 3 cups of sugar. Let's check to see if that works. So to get my 3 cups of sugar, I need to multiply the 1 by 3, which is 3, and then the 3 multiplied by 3 is 9. So for 3 cups of sugar, you need 9 cups of flour. So there's your 3 different ways of showing ratios visually using a double number line, a tape diagram, or graphing. 3 different ways. Choose the one that you like best. I happen to like the tape diagram, but again, whichever one makes most sense to you. And I hope this helps explaining it visually for you.